What is the rate of change of a function? Well, I've drawn the graph of a function f here, and notice that the function seems to be trending upward as we move left to right. Now, that's not always the case. It looks like the function is decreasing right in here. But we could ask, how fast is the function changing at some point? Or what is the rate of change of the function at that point? And notice that at some places, the function seems to be changing only gradually, like right in here. Whereas other places, like over here, it seems like the function is changing more rapidly. And so the rate of change of a function at a point, sometimes called the instantaneous rate of change at that point, will just be the slope of the tangent line there. Now, in this video, we're only going to be interested in the average rate of change of a function. So if we looked at 2 points, A and B, so let me draw in 2 points here. So let's say this is A, let's say this is B. We could ask, what is the average rate of change of the function between these 2 points? Or how quickly is the function changing on average between those 2 points? And what that's really asking for is the slope of the secant line between those 2 points. So we could draw in A comma f of A and B comma f of B. And if we were to look at the slope of the line that connects these 2 points, so the rise over the run, the change in y values divided by the change in x values, that would tell us how quickly the function is changing on average between A and B. So we have this definition: the average rate of change of a function f between x equals a and x equals b is given by this formula, f of b minus f of a over b minus a. That's really rise over run, or the change in y values divided by the change in x values. And like I just mentioned, this is just the slope of the secant line between x equals a and x equals b. So here's a picture of a function f. And the slope of that secant line between A and B, the slope of that blue line, is just rise over run. Okay, so that's f of b minus f of a, that's this distance, divided by b minus a, that's this distance. So let's look at an example. Find the average rate of change of the function f of x equals 1/4 x squared minus 2x plus 7 between x equals 2 and x equals 8. Okay, so we're going to draw a graph of this in a minute here, but let's do this just based on our definition. So our definition was f of 8 minus f of 2 divided by 8 minus 2. Okay, now what is 8 minus 2? Well, that's easy. That's just 6. The change in x values between these two is just 6. What about the change in y values, or the change in output values? Well, what is f of 8 and what is f of 2? Let's just kind of do this in our head. F of 8, if we plug in 8 here, we're going to get 64. 8 squared is 64 times 1/4, that's 16. But then 2 times 8 is also 16. So we have a 16 minus 16, that's 0, plus 7. Turns out that f of 8 is 7. Okay, and then what is f of 2? Well, if we plug in 2, we get 2 squared is 4. 4 times 1/4 is just 1. And then 2 times 2 is 4. So we have 1 minus 4, that would be negative 3, plus 7, that would be 4. Okay, so just to be clear here, f of 8 was 7, and f of 2 was 4. Okay, and when we work out the details, notice that we get 3 in the numerator, 6 in the denominator. So 3/6 is the average rate of change, or we could reduce that to 1/2. 1/2 is the average rate of change of this function between x equals 2 and x equals 8. Now, here's a Desmos graph of that function. And notice you see the points 8 comma 7 here. Remember, f of 8 was 7, and 2 comma 4. F of 2 was 4. And if we draw the secant line that connects those 2 points, what we're really asking for when we ask about the average rate of change of this function between 2 and 8 is, what is the slope of that secant line? Okay, and notice we just need to do the rise over the run. And the rise was f of 8 minus f of 2, right? F of 8 was this value 7. F of 2 was this value 4. And so that when we subtract them, we get 7 minus 4, which is 3. Okay, and then the run, of course, is just 8 minus 2, which is 6. And so therefore, the average rate of change was this by definition, and when we simplified it, we get 1/2. Okay, let's look at a real world example. The price of one share of Costco stock at the beginning of 2014 was $118.78. And I looked it up, and that's approximately what it was. And the price at the beginning of 2024 was $655.58. Find the average rate of change of the stock price between 2014 and 2024. Now, notice all that we really know about the stock price is these two data points. We don't know what happened to the price of the stock between these 2 years, 2014 and 2024. We don't know how it was increasing or decreasing. It may have dipped down below here and then gone way up. We don't know. But these two values are enough information to tell us what was the average rate of change of the stock price between 2014 and 2024. So let's just say the stock did something like this. Okay, this is not going to be exactly accurate, but say it did something like this. Okay, how could we find the average rate of change? Well, what we need to do is to find the slope of the secant line that connects those two values. So if we thought of the stock price as being a function f, what we're really looking for is what is f of 2024 minus f of 2014 divided by 2024 minus 2014. Okay, and 2024 minus 2014, that's really just going to be 10, right? Because that's the 10-year interval here. Now, f of 2024 would be this 655.58 number. And f of 2014 would be this 118.78 number. So let's subtract these. And I used a calculator and got $536.80. That's how much the stock price went up. That's the difference between these two values, $536.80. But that happened over a 10-year interval. So when we divide by 10, we get 53.68. 53.68. Now, what does that mean? Well, that means on average, the stock price was increasing at a rate of $53.68 per year. So the units on this would be dollars per year. Okay, so when you talk about a rate of change, it's always the units will always be the units of the y divided by the units of the x. Okay, so this would be $53.68 per year. Okay, so when you're doing these problems, the units for a rate of change will be the y value, the units of the y divided by the units of the x. Finally, the wording of the question could be a little bit different. So for example, instead of being given like f of x equals x squared, we could be given this in terms of y equals x squared. Now remember, our formula for our average rate of change was f of b minus f of a over b minus a. Well, how could we do this in terms of y? You could think of this as like y of x equals x squared, and then the formula would just be y of b minus y of a over b minus a. Usually we don't write y of x, but it would be totally fine to write it like that. Just remember that this does not mean y times b, right? It's y of b, y of a. But then also the question could be worded a little bit differently like this. So find the average rate of change of y with respect to x if x changes from -2 to 3. Well, before we were saying between x equals -2 and x equals 3, but you could say find the average rate of change of y if x changes from -2 to 3. So how could we do this? Well, what we need to do is find the y value when x is -2 and find the y value when x is 3. So we could write y equals -2 squared, which would be 4. So in other words, this is really y of -2. Y of -2 is -2 squared, which is 4. What that really means is the ordered pair y comma or -2 comma 4 is on the graph. We could also write y of 3 equals 3 squared, which is 9. So again, I just wrote it y equals this, but you could write y of 3. So what that means is the ordered pair 3 comma 9 is on the graph. So again, we're just going to look at the slope between these 2 points. So that the difference between the y values, the change in y values, divided by the change in x values. So it's going to be 9 minus 4 over 3 minus a -2. So that would be 5 over, well, 3 minus a -2 is like 3 plus 2, be 5 over 5, which is 1. So we could graph this though. So notice I've graphed the function y equals x squared right here. And we were asking between -2 and 3, what is the average rate of change of this function? Well, notice here's the ordered pair -2 comma 4. Here's the ordered pair 3 comma 9. And so the question is really, what's the slope of the secant line that connects those 2 points? Well, what is the rise between the 2 points and what is the run between the 2 points? Well, notice the run is 5. To get from -2 up to 3, the run is 5. And the rise, in this case, is also 5, right? To get from a height of 4 up to a height of 9, that's also 5. So the rise over the run here, the slope of that secant line, is 5 over 5.